Hello everyone. So I hope you are fine. And now this also chapter will go on. We are on the verge of completing. Only nearly 5 to 6 theories only are remaining. Others all have completed mostly. Now only theoretical portion is remaining. That is one CFT is remaining. Valence bond theory is remaining, and optical isomers. Stereo isomers are remaining, and stereo isomers are very easy, so not an issue. Okay, so today I am going to complete your structural isomerism. Last class up to hydride isomerism I have done, and number of questions also we have solved on the base of the hydride isomerisms. Hydride isomerism, I told you that it is one type of a ionization isomerism. For a hydride isomerism, the condition is you should see whether the given question is of an ionization isomerism or not. Clear? So, and we have seen the distinguish between the H2SO4 and HgNO3 also, and distinguish means reactions. That also I explained it to you. Clear? So today I am going to in detail about linkage isomerism. See here. So make a heading, linkage. Another name of a linkage is coordinate, not coordination. Coordinate isomerism. Okay, so linkage or coordinate isomerism. Now see, if in any coordinate complex, if you see the ambident ligand, then that type of a isomerism is known as a linkage or coordinate isomerism. Write down. If there is a presence of ambident ligand, then that type of isomerism, that type of coordinate complex are known as linkage isomers of each other. Okay, we know ambidentate ligand, you know, these are the one type of a monodentate ligand. These are the one type of a monodentate ligand, yes or no? Or bidentate ligand, they are one type of a monodentate ligand. They can donate, they have two donating sites. Yes or no? Best example is NO2 or ONO. At a one time they can donate only either from N or from O. Both cannot donate. No, both cannot donate. This we have discussed in the previous classes. Both cannot donate. So ambidentate ligand are such a type of a ligand which have a two donating site, but at a time only one can donate. Ambidentate ligand have a two donating site, but at a time they can donate only from any one side. That's why NO2 nitrito N and ONO nitrito O. Yes or no? So this NO2 and NO are both same only, because NO2 is a ambident ligand. At a time only from one side only ligand can, lone pair will come. So that type of a ligand if you see in the isomers, so that type of isomers we say as a linkage isomers. The compound having a same molecular formula, but if there is a presence of ambidentate ligand or the donating side of a same ligand is different, such a type of a ligand we say as a linkage or coordinate isomerism. See example of ambidentate ligand we will see. Example is if there is a presence of NO2, so NO2 will be having which ligand? ONO. Yes or no? Or we can say SCN minus, or it will be NCS. Yes or no? Then we have OCN minus, though we have a NCO minus. Yes or no? These all are an example of an ambidentate ligand. Then we have NO2, I have written H2O32 minus. Yes or no? So the number of are there which are there. So you will see the example. See the examples here. See first example. Question number 1. See here. CO NO2 NH3 5 plus 2, okay, and CO ONO NH3 5 plus 2. Clear? So they are the linkage isomers of each other. Why? See, compound having the same molecular formula. CO is 1, CO is 1, NO2 is 1, NO2 is also 1, NH35, NH35 plus 2, yes, correct. So compound having the same molecular formula but different. See, here the linkage is through N, so this is nitrite to N and this is nitrite to O, so they two are linkage isomers. Yes or no? See, here the linking is through N, that's why it is written NO2, and here the linkage is through O, that's why it is written ONO. So this is nitrite to N and this is nitrite to O. So these two are the example of linkage isomers. Yes or no? Second example, Cr NH3 thrice Cn thrice minus 3 and Cr NH3 thrice NCS3 NC minus 3. See here. First we will scan this and we will see compound having the same molecular formula. Cr is 1, Cr is 1, NH3 is 3, NH3 is 3, cyanide is 3, cyanide is also 3 here. Now see here the cyano N, isocyano N. Yes or no? This is cyano, this is isocyano, because here bonding is through C and here the bonding is through N. The compound having the same molecular formula but different type of a ligand bonding. Here the same type of a ligand but different site bonding. Here the bonding is through C, here the bonding is through N. Ligand is also same but the bonding is different, bonding of the atom is different. Here the bonding is through C but here the bonding is through N. So this is also an example of a linkage isomerism. So linkage isomerism, what you have to see? We have to see the M.B.dentate ligand. Wherever if you find the M.B.dentate ligand, close your eyes and give that an example of linkage isomerism. Third example we will see. And you know that compound having the same molecular formula, when bonding also change, property also changes. Why? See this example. Third example. The third example is CO NH3 5 SCN plus 2 and CO NH3 5 NCS plus 2. See again they are the linkage isomerism. Compound having the same molecular formula. See CO is 1, CO is 1, NH3 is 5, NH3 is 5, SCN and here NCS. So ligand is same but bonding site or donating site is different. Here the donating site is S and here the donating site is N. So donating sites are different. So compound having the same molecular formula but different donating sites, or there is a presence of M.B.dentate ligand, then this is an example of a linkage isomers. So when see beta, isomers means what? Compound having the same molecular formula but different properties. So here also property will change. When ligand site will change, property will also change. How I came to know? Because when I see this compound is of an violet in color. But this compound, if I see, this is an orange in color. Yes or no? Why this happens so? Because the compound, when the bonding get changed, this is orange in color. When the M.B.dentate ligand bonding change, donating site changes. Here donating site is S, due to which it is a violet in color, and here the donating site is N, due to which it is an orange in color. So when the donating site changes, the property also changes. So this type of isomers is also linkage isomers. Fourth example we will see. CO NH3 5 NO2 plus 2 and CO NH3. So this is only the example, no? NH3 5 ONO plus 2. So this is which in color? This color, this is in yellow and this color is in a red. See, first scan it. Compound having the same molecular formula. See, CO is 1, CO is 1, NH3 is 5, NH3 is 5, NO2 is 1, NO2 is also 1 here. So compound having the same molecular formula, but see the ligand connection, donating site is different. In the first case, the donating site from the ligand is nitrogen, and in the second case, the ligand donating site is O. So this we call the nitrite to N and this we call the nitrite to O. So here ligand is same, but the donating site is different because they are M.B.dentate ligands. So this type of isomers we say as a linkage isomers, and you can see when the donating site differ, so they also property also will differ. That's why it is in yellow in color, it is in red in color. Clear this part? So these are the example of certain example of linkage isomers. Clear? So write down one small note. Write down one small note on this. Okay? Write down. NO2 minus ion combine. NO2 minus ion combine with the metal ion through coordinate and act as nitrito N ligand and act as nitrito N ligand, nitrito dash N ligand. Okay, and in another compound it act as a nitrito O ligand into bracket O NO minus. In another compound it act as a nitrito O ligand, that is O NO minus. Thus one ligand forms isomers. Thus one ligand forms isomers by bonding of different atoms. Thus one ligand forms isomers by bonding through different atoms, that is different donating sites. That is the different donating sites. That is a different donating site. Examples are given below. Write down these all examples. Clear? So in this way you have to solve the problems. Clear? So this is your linkage isomers, and sometimes in the question they will ask you as a coordinate isomers also, not an issue. If they give you coordinate isomers or linkage isomers, one and same. But coordination isomers, it's different. Clear? Okay? Now see here. Now next topic I am moving towards, that is the coordination isomerism. Clear? Chalo. I hope you have taken the screenshot. We are on a verge of completing the structure isomerism. Okay, 2-3 questions will solve and we will wind up. Tomorrow's class is very important because the next class I will solve with the stereoisomerism. See here. So next is coordination isomerism. Coordination isomerism. First you see the example, automatically understand. See, in coordination isomerism what happened, you know? That is both the cation and anion and complex form. See, both cation and anion are in complex form. Don't write down, first you see, then you will understand in detail. See, on an example I will give you. First example is Cu NH3 4 plus 2 and PtCl4 minus 2. This is first compound, yes or no? And Pt NH3 4 plus 2 and CuCl4 minus 2. See here, compound having a same molecule. These two examples, if I don't write only a plus 2 and minus 2 also will work. See this now. Okay. So you know these are the complex in which cation and anion both are in complex form. So whenever the cation and anion are both are in a complex form with the same molecular formula, we call as a coordination isomers. See here, compound having a same molecular formula. Copper is 1, copper is 1. NH3 4, NH3 4. Platinum 1, platinum 1. Chlorine 4, chlorine 4. Now see here. Here there is a copper and here there is a platinum. But now here there is a platinum and here there is a copper. Ammonia and chlorine are remaining same. You can see here. Just the cation, just the places has been changed. See here. So compound having the same molecular formula. If you write down the molecular formula, see what will be the molecular formula? CuPt NH3 4 Cl4. This will be your molecular formula for this compound. Similarly, this will be your molecular formula for this compound also. See, CuPt NH3 4 Cl4. See here this. So compound having the same molecular formula, but see the places of cation. See here copper is here with ammonia, but here copper is with the Cl4. Similarly here platinum is with the chlorine, but here Pt is with ammonia. So this type of isomers, whatever you see, which we call as a coordination isomers. Clear? So first of all, first step is what? If both are in the complex form, then it can be coordination isomers. Then you have to see same molecular formula, yes. And then you see the places of central metal atom. See, it is changing. So this type of a complex we say as a coordinate coordination complex. Coordinate complex or linkage complex, one and same. Coordinate complex and linkage complex, both are same. Coordinate isomers, linkage isomers. So both are same. Either you tell linkage isomers or you say coordinate isomers. Coordination isomerism. This. Clear? See, I'll give another example. We'll see another example. CO, NH3, 6. And here we are down Cr, CN6. Okay, and Cr, NH3, 6, and CO, CN6. Okay, see here now. See, compound having a same molecular formula. Here CO is 1, CO is 1, NH3 6, NH3 6, Cr1, Cr1, and Cn6, Cn6. See the places of cobalt. Here cobalt is with ammonia. Here cobalt is with cyanide. Here Cr is the cyanide, Cr is ammonia. So compound having a same molecular formula. Here compound is having a same molecular formula. But you see both are in a complex. So this type of isomers we say as a coordination isomers. Another example we will see. Third example. CO, NH3, 6. CrCN6, same example la. Okay. Not to write down. Third example. Zn, NH3, 4. Here it will come CuCl4 and Cu, NH3, 4 here, ZnCl4. Clear? The compound having a same molecular formula. Here Zn is 1, Zn is 1, copper is 1, copper is 1, NH3, 4, NH3, 4, Cl4, Cl4. So see here, if you see closely observed, here cation and anion both are in complex, and see the position of Zn and Cu, just they are alternating, but compound having a same molecular formula, but both the cation and anion in a complex form, then this type of isomers we say as a coordination isomerism. Clear this part? Chalo. So I'll give you the notes, write down the notes, then we will move to the 2-3 questions. Okay? Then we'll move to the 2-3 questions are there. We'll move to that. Write down. When, write down and make a heading, coordinate isomerism. Make a heading, coordinate isomerism. When in coordination compound, both positive ion and negative ion are in complex. Both positive ion and negative ion are in complex. Both positive ion and negative ion are in complex. And there is an exchange between. And there is an exchange between. And there is an exchange between. And there is an exchange between the two in the coordination sphere. And there is an exchange between the two in the coordination sphere, and isomers are formed. And isomers are formed. This type of isomers are called as coordination isomers or position isomers. This type of isomers are called as coordination isomers. Only do not know position. Coordination isomers. Clear? You can write down these examples. Then move to the next. We'll do one question based on the isomerism. Write down this example. Okay? See, read it and try to solve the question based on this isomerism. Okay, if you go on solving the questions based on this isomerism, then only you will get it, the answers. Now here I am going to today discuss one question I will going to discuss, and two questions are there. That questions we are going to see. Stability of a complex. First I will, if you write down the whatever the points, if I tell you, if you write down, that points are enough for you. Okay, clear? Okay, chalo. So write down the next question here. One question you write down. Two compounds having molecular formula CrNH3 thrice, CrNH3 thrice, NO2 thrice, NO2 thrice in aqueous solution, in aqueous solution, one of this compound these compounds will conduct electricity, while other do not. Conduct electricity. Given that two molecule of H2O get attached to a complex in aqueous solution. Write the possible structure of A and B. This is the question. Okay. See, first you understand this question. Two compounds. So there are two compounds having a molecular formula. Means molecular formula is same. Which is the molecular formula? The molecular formula is CrNH3 thrice and NO2 thrice. Okay. In aqueous solution, one of this compound will conduct electricity. Means he is making two compounds. Say compound he is making A and he is making B. Where? When in aqueous medium. Means when I am adding in water. So in aqueous medium he is making two compounds A and B. One of this compound will conduct electricity. So suppose A conduct electricity. This A conducts electricity and this B does not conduct electricity. Doesn't conduct electricity. Given that two molecules of water get attached to a complex. So here when this happens, so two molecules of water get attached to the complex. So in aqueous solution, right? The possible structure of A and B. Now beta, there were two compounds which are, these two compounds are formed from this only. Yes or no? The two compounds, whatever they have formed, the two compounds have been formed from this only. Okay, and one compound conduct electricity, but for the condition for the conduction of electricity is what? Ions should be present. Ions are present outside of coordination sphere. हाँ क्या ना? अगर coordination sphere ની बार ions present હશે तो જે split કરશે ને split કરશે તો ionic solution બનશે ને ion flow કરશે તો electricity flow થશે. So ions are present, ions should be present outside the coordination sphere. हाँ क्या ना? sphere. And doesn't conduct electricity means ions are, so outside ions are not present outside. Ions are not present outside the coordination sphere. Yes or no beta? Yes. मतलब એમાં આયન્સ પ્રેઝન્ટ હોવા જોઈએ તો પાણીમાં જો છૂટા પડે આયન્સ બને ઇલેક્ટ્રિસિટી કન્ડક્ટ થશે. આ કહે છે કે આમાં ઇલેક્ટ્રિસિટી કન્ડક્ટ નહીં થાય, મતલબ બહાર આયન્સ પ્રેઝન્ટ નથી, છૂટા નહીં પડે તો ઇલેક્ટ્રિસિટી કન્ડક્ટ થશે નહીં. મતલબ outside can be outside of coordination sphere can be neutral molecule. हाँ के ना, अगर outside of the, if I keep the neutral molecule outside the coordination sphere, so they will not get ionized, and when they will not get the ionized, they will not conduct electricity. So what can be the possible structure? So see, when this compound which is having the molecular formula I dipped in the water, he also get how many water? He got 2 molecule of water. He got 2 molecule of water. So I have written here 2 molecule. Now one we have to see which is conduct electricity and one we have to see which does not conduct electricity. So take a screenshot, then I'll move to the next. Take it? See here. Now see how it's possible. See. So first we have to see one which conduct electricity, and for the conduction of electricity ions present should be must. So see here. This Cr, if you see here, see this is neutral. This is neutral, but this is an anion. So NO2 is minus here. I told you last also. NO2 means minus, means here chromium is having plus 3 charge. Chromium is having how many charge? Plus 3 charge. When chromium is having plus 3 charge, so here already showing that chromium has to form 6 coordinate covalent bond. 6 coordinate covalent bond. Matlab, whatever you do, here chromium they are showing they have to be formed how many coordinate covalent bond? 3 plus 3, 6 means chromium should be present in chromium, whatever complex you write down, that chromium should have a 6 coordinate covalent bond. See, so first they are telling the ion should be present and another ion should not be present. Sorry, ions for first will conduct electricity. For conduction of electricity, ions must be present. Now who is the ion, who is in this compound, who is having the ions? So this is the ligand which is having the ions. So this will conduct electricity. So if I write down this in this way, Cr NH3 thrice, and here NO2 twice if I write down, and 2H2O. See here, if I write down here NO2, so this will separate as plus and minus. Yes or no? This will separate as plus and minus. So they will, when I put in the water, they will separate it as ion. So they will separate it as ion. So they will conduct electricity. But see, I told you chromium can have a maximum capacity to form how many bonds? So chromium will have a maximum to capacity 6 coordinate covalent bond. Now see the chromium bonding. 3 plus 2, 5 plus 2, 7. So what I will do? Instead of 2H2O, 1H2O, I write down outside. Or you can write down NO2 by, so either you can write down 1H2 outside, or instead of 2NO2, 1NO2 here and 2NO2 outside. So this is also possible. So A compound can be this which conduct electricity. Another A compound can be which beta? Either A can be this also, Cr NH3 thrice. I cannot put ammonia outside because ammonia is a neutral ligand. It will never form ions. Ions capacity is forming NO2 only. If I put NO2 outside, then only splitting will occur and ions will be formed and electricity will be conducting. So Cr NH3 thrice, or I can write down in this way also, NO2. Yes or no? Chromium has a capacity to make how many bonds? 6. So Cr3 plus 1, 4, 2H2O. So chromium capacity is over. Chromium can make a 6 bonding. So 3 plus 1, 4, 5, 6. Now NO2 how much I written? NO2 was 3. So NO2 outside will be now how much? 2 will be coming. So this also compound is possible. A can be this or it can be this. Completely NO2 I cannot write it outside. Completely NO2 I cannot write down outside. Why? See here, A equal to Cr NH3 thrice 2H2O, because maximum water how much he is taking? 2 water only he is taking. So Cr, chromium has to make 6 coordinate covalent bonds. So 3 ammonia and 2 water, so 5. So NO2 completely 3 I cannot write outside. So this compound is never possible. Because chromium should make how many bond? Maximum 6 bond. Here only 5 bond are possible. So 1 NO2 has to be inside. So either this is possible or this is possible. A can be this or this. Both answer is correct. Both answers are correct. Clear? Written this, so they will conduct electricity. Why beta? When you put in the water, they will form as a plus, they will form as a minus. They will form as a plus. This portion will form as a plus and this portion will form as a minus. So this will conduct electricity and they need a one isomers which conduct electricity. Now we'll see about B. Written this, write down this. So A, first compound can be this. We'll add another. Another they need a isomer which does not conduct electricity, means which cannot form the ions. So Cr, NO2 means always NO2 should be out inside only. So either this compound is possible, NH3 thrice into 2H2O. So this is the answer. Or another answer can be also possible. B, Cr, NO2 can never be outside, because if you put NO2 outside, over, game over. Because the reason is NO2 if you keep out, they will ion, they will split it and they will conduct electricity. But the B compound they need which does not conduct electricity. So see, here they will not get ionized because this water is a neutral molecule. So they will not get ionized, they will not form ions. When they will not form ions, they will not conduct electricity. So another compound can be here, NH3 twice. Now chromium has to make capacity 6 bonds. So 3 plus 2, 5. So one H2O bring inside. So answer will be NH3 twice into H2O. This also can be possible. Another B, what is possible? Cr, NO2 thrice, NH3 and then 2H2O. So 3 plus 1, 4 plus 2, 6. So how many NH3 were there? 3. How much I have put inside? 1. Outside how many now? NH3 are 3 only, no? So NH3 1 will come outside. Sorry, this will be the compound now. See? Yes. Now NH3 were totally 3. So out of 3, 1 only I have put inside. Outside will be NH3 twice H2O. This also is possible. Yes or no? Another? Cr, NO2 thrice 2H2O. Can I put all the NH3 3 outside? See. Why no? No. The reason is chromium has a capacity to make 6 bond. See the bond here. 3 plus 2, 5. One more is, so one NH3 I have to bring ultimate inside only. So this B is not possible. So B answer can be either this or this or this, which will not conduct electricity. Why they will not conduct electricity? Because when you put in the water, they will not get ionized, because they are not a they are a neutral molecule. All are neutral. NH3 also a neutral molecule, water is also a neutral molecule. So either B will be having these 3 answers and A will have that 2 answers. So check it out in the option and tick the correct answer. Write on this. Done. So in this way, this type of a questions you have to solve. Clear? Chalo. So now we'll go to the next topic, that is the stability of complex. Okay? Written this, understood this. Today I am going to give you one series. That series you have to remember, and 2-3 definitions I will give you, then I will wind up the lecture. Explain the stability of a complex compound. Explain stability of complex compounds on basis of strength of ligands. Strength of ligands. See beta. First we know that ligands are attached to the central metal atom and they are forming a coordinate covalent bond, and such type of a compound are known as a coordinate covalent compounds. As the ligand is the stronger, the more strong compound will be there. As the ligand is weaker, weaker compounds will be there. So there is a one series. This series you have to remember for the ligands. Cl minus is less than F minus is less than OH minus is less than H2O. NH3, still number are there, but here simple only I am showing. So these are the ligand strength. So see, chlorine is the weakest ligand, then fluorine, then OH. So if cyanide is attached to a certain complex, then understand that complex is having the higher stability as compared to the ammonia, water, OH minus, F minus, Cl minus. So in this way you have to identify the strength of the complex. See, write down. As the strength of, write down this. As the strength of, this is a theoretical concept, no question will come on this. Write down. As the strength of different ligand, form, as the strength of different ligands to form coordinate covalent bond varies, as the strength of different ligands to form coordinate covalent bond varies. Stronger ligand possess more attraction. Stronger ligand possess more attraction with metal ion. Stronger ligand possess more attraction with metal ion. As a result, complexes having a stronger ligands, possess more stability. As a result, complexes having a stronger ligands possesses more stability, and complexes having a weak ligand possesses less stability, and complexes having a weak ligand possesses less stability. Hence, as a result, complexes having a stronger ligand possesses more stability, and complexes having a weak ligand possesses less stability. Clear? Chalo. Next, hence it can be said that the strength of complexes is determined on the basis of strength of ligand. Hence the strength of complexes is determined on the basis of strength of ligand. The basis of strength of ligand can be determined by same metal ion. The basis of strength of ligand can be determined by same metal ion combined with different ligands. Hence, change in capacity required is seen. Change in the capacity required is seen in the information of complex ion of metal ion. In the information of complex ion of metal ions, and the ligand series is as follows. Write on this. And the ligand series is as follows. Write down this series, beta. Clear? Okay. So see now, if you remember this series is important. Cl minus, F minus, OH minus, H2, NS3, Cn minus. Okay. Now here I have completed your structural isomerism. Next class I am going to give 2-3 more definitions, and next class I am going to discuss about a very important topic, that is your geometric, or I can say that isomerism based on that optical isomerism, and that all isomerisms I will do the stereo isomerisms. So that stereo isomerisms you have to be very careful. It is not so easy as it was easy like structural isomerism. In structural isomerism, what you are doing better, just we are seeing and we are telling. Just you have to visualize. Just you remember like ionization isomers means what? Just which either type of ions or number of ions. Then hydrate isomers means what? Hydrate isomers means number of water molecules. Then it was a linkage isomers or coordinate isomers. So that it is depend on the M.B.-dentate ligand. Just if you see M.B.-dentate ligand, if you practice the examples, 15-20 examples, it will be clear for you. And last was nearly which last was your that M.B.-dentate example over, and last was your coordination isomers. Means just if a cation and both are in complex, and if I ask you to find the isomers, just close your eyes and tell that this is coordination isomers. Just to see the places of the center metal atom, it will get changed. First it will be in a cationic complex, and second part will be in anionic complex. So that was very easy. You can practice this again, understand definition. If you don't know, understand. If you don't know this topic, again revise my videos once more, thrice, 4 times, 5 times, see the videos and solve the problems. But then our problem will come, that is in the stereo isomerism, and stereo isomerism is bit difficult and bit very important for this chapter. So you have to practice well. Till now, if I committed any mistake, you can please comment me. You guys are not commenting. Why I don't understand. If I am not teaching good, give me bad comments. so that I can improve myself. You can comment me whatever issue you have, you can comment me on the YouTube channel, or you can give me the software. I'll revert you back within a 24 hours. You'll get the answers. Clear? So for today, here itself. Next class, I will go with the stereoisomerism for the next class. Thank you. Have a nice day.